The other fun and exciting thing we're going to do in 1.4 is called radical equations. So we have to have some sort of radical coming from the root word rad. And kind of the first thing we want to do is we want to isolate the radical, and then if it's a cube root, we'll cube it. If it's a square root, we'll square it, because the cube and the cube root undo each other. The square and the square root undo each other. I think we mostly do cube and square roots, mostly square roots. In this particular example, we have a cube root. So what we're going to do is we're going to cube both sides, and I mentioned that the root is isolated, so that's good. So we're going to cube both sides. The cube and the cube root undo each other. And the nice thing about us, 0 is 0 cubed is 0. To make this a little bit easier, because I want to try to factor it, the left-hand side is a polynomial. 1 minus 2x minus 3x squared. I like the x squared to be positive, so if we divide everything by -1, that'll change everybody's sign, and then I'll just rearrange. So the negative and a negative here, that makes a positive 3x squared. Negative and a negative makes positive 2x, and then we'll have a minus 1 equals 0. Go ahead and factor that, and then set each factor equal to 0, and then we'll solve both of those linear equations. And then we'll go ahead and we'll check them. So we're going to go ahead and check them in the original equation, and they should equal 0. Alright, so I'm going to go ahead and maybe talk a little bit about the checking here, not a whole lot. So here's the 1/3, and here's the 1/3 squared. 2 times a third is 2/3, and then 1/3 squared is going to be 1/9. Well, then we're going to multiply it by 3. So 3 times 1/3, or sorry, 3 times 1/9 will be 1/3. So that's where that comes from. All right, and all that wonderful stuff ends up being just 0. And then take the cube root of 0, which is just 0. Get a smile and a happy face. Checking -1 is a bit easier. And again, we get 0 and a smiley face. So both of those answers are good. Okay. Let's look at another example. We have x equals 8 square root of x. The square root is isolated here enough. The 8's there, but this is good enough. So what undoes a square root is a square, so we're going to go ahead and square both sides. X squared equals 8 squared is 64. The square root and the square undo each other, so we have just regular old x. This is a quadratic. Most of the time we set it equal to 0, and that's what we're going to do here. So I'm going to subtract 64x from both sides. X squared minus 64x is equal to 0. GCF is x, so we factor an x out. And then we set each factor equal to 0, and we'll get x is equal to 0, or x is equal to 64. I'm going to go ahead and check. So if x is 64, plug 64 in, and we get 64. That's great. Plug in 0, we get 0, so we get smiles and happy faces. So the original equation wasn't equal to 0, it was equal to x. So if I plugged in 64, I should get 64 out if that's going to be true. If I plug in 0, I should get 0 out if it's going to be true. And in fact, I do. Alright, we'll do one more. So we have x squared minus x minus 4 equals x plus 2. And the square root is isolated, so we're going to go ahead and square both sides. Square and the square root cancel each other out, x squared minus x minus 4. And then on the right hand side, we're going to FOIL that out, and that's going to be x squared plus 4x plus 4. The x squareds are going to cancel. If I subtract x squared from both sides, they're gone. This is now a linear equation, so we want one side to have the x's and the other side to have just the numbers. So we're going to add the x's to the right, and we're going to subtract the numbers over to the left-hand side. So we have -8 equals 5x. We'll divide both sides by 5, and -8 over 5 is equal to x. We'll go ahead and check. So we're going to check on the left-hand side. Okay, so -8/5 squared minus -8/5 minus 4. That's going to be 64 over 25 plus 40 over 25. The plus comes from because you're subtracting a negative. I want common denominators, so I multiply the numerator and the denominator by 5. 8 times 5 is 40. 5 times 5 is 25. 4 is the same thing as 100 over 25. Common denominator, we get 4 over 25, which reduces to 2/5. So that's the left side. The left side equals the right side, and this is a true statement, and that is a solution. Now we're going to take 8/5, negative 8/5, and add 2 to it. So 2 is the same thing as 10 over 2, and we in fact get 2/5. So we give ourselves a check mark and a smiley face because this one worked out just fine also.